Hello everybody, I am Krishna Rao Patro. Today I will discuss about one more important concept of thread, that is inter-thread communication. How two threads can communicate each other with cooperation nature. When there is a common source, how the common source can be utilized between two threads with mutual understanding, with cooperation. So that means one after other. One will be using that particular resource, then other has to wait. Once you do the task, then you will send a notification. After sending notification, other thread, whoever is waiting, he will use the resource. So that communication mechanism that we will discuss now. So what is our topic? The topic is inter-thread communication. How two threads can communicate each other with a cooperative way. Inter-thread communication is a mechanism that allows thread in a multi-threaded program to communicate with each other and coordinate their activity. It should coordinate their activity. So, a common resource should be utilized by multiple threads. So, in Java, this communication is typically achieved through the method called wait, notify and notify all. There are two special methods in Java. One is wait method, notify method and notify all methods. Notify all methods that provide by a special class called object class. Actually, in Java, the parent class or the grandparent class is called object class. In object class, these three methods are there: wait method, notify method, and notify all. Under which class? Under object class. This class is built-in class. So wait method is here. Wait, notify all. This method we can use for communication. So if somebody is using, other has to wait. Once somebody's work is over, he has to notify. So there will be agreement between the two threads. One will execute wait, another will execute notify. Whoever is going for waiting state, he will be keep on waiting for notification signal. Once again the signal comes, he will activate it and do the task. This mechanism enables the thread to synchronize their execution. So, whenever one thread is inside a critical region, means a common resource area, there that area must be synchronized area. So that as long as he is using that resource, other has to wait. That is the main concept here. So, here you have to do what? Synchronization. And share the information in a controlled manner. So that information should be used by both the thread, but only one can be used at a time. So whenever the first thread is using, other thread has to wait. And whenever this thread completes its task, and its responsibility is send a notification, so that the fellow who is waiting, he will activate. So that is the thing. So they will be standing in a queue to use the resource. Now, a typical problem is called producer-consumer problem. Producer-consumer problem. This problem is the best example for inter-thread communication, ITC, inter-thread communication. Now, the producer is one thread. This is first thread. The consumer is second thread. The pipe data stream is my resource. This is my resource. This resource will be utilized by producer as well as utilized by consumer. The duty of producer is to produce something. The duty of consumer is to consume something. Here, the producer is producing something, that means writing something to where? Into the piped data stream. Whenever this fellow is writing, then the consumer thread, that means the reader thread, it has to wait. This is writer thread, this is reader thread. The consumer thread cannot read until this fellow writes. So, this fellow will be keep on waiting until the thread writes. Or this fellow cannot overwrite multiple lines until this fellow reads. So that means there is a cooperation between the two threads. Write one line, read one line. Again write one line, read one line, because your capacity is this much only. In that area, you can write only one line of sentence, for example. For example, you can write only one line of sentence. After writing one line of sentence, this must be read by another thread. Once this thread completes reading task, then this fellow, again he can write. After writing, this fellow can read. When the consumer is reading, it will check whether anything is there or not. If it is there, okay, it will read. Otherwise, it will wait. Similarly, when this fellow is writing, this fellow has to wait. So like this, you have to cooperate. That means write one line, read one line. Write, read, write, read. So for that, you have to use wait and notify. These two methods I have to use to solve this problem. So this is a producer-consumer problem. And now we'll see how wait works and how notify works and how notify all works. These are the, I told you these three are the important methods useful for inter-thread communication. And these three methods are part of which class? I told you these are the important methods of object class. The wait method is used to make thread wait until another thread invokes the notify. As long as another thread is not giving notify, it has to wait only. If this fellow sends a notification, then the wait thread will activate. Yeah. Now the wait method is used to make a thread to wait until another thread invokes notify or notify all. There is a difference between notify and notify all. Notify will send a notification to only single thread. Notify all will send notification to all threads who are waiting. So if you want to send a notification to all thread, go for notify all. If you want to send a notification to only single thread, go for notify. So whichever is useful for your application, use that one. If you say notify all, it will go to all threads who are waiting. When thread calls wait, then release the lock on the object and enter the waiting state. Okay, whenever it calls wait, then it will be going for waiting state. It means that waiting the state until the thread invokes notify or notify all on the same object. Whatever the resource you are using, that resource, whoever is using, that fellow, whenever its task is over, it will send a notification. Yes, my work is over. Please, you come and do the task. So the fellow who is waiting to use the resource, they will wake up. So that only one thread will come and use. Because multiple threads are not allowed to use the same resource at the same time. Then there is a method called notify. The notify method is used to wake up the single thread. Wake up single thread that is currently in the waiting state due to the previous call to wait on the same object. If multiple threads are waiting, only one of them has to be chosen is a wicket. Multiple threads are there, but only one to be used. In that case, notify. Then one more is there, notify all. If notify all method is used to wake up the all threads on the currently in the waiting state due to the previous call of wait on the same object. On same object, if multiple threads are waiting, then go for notify all. This method is often prepared to notify to avoid potential issues like missed signal. Sometimes some threads may be missing the signal. In that case, better to go for notify all. Now we'll see the classical problem, that is producer-consumer problem. Producer has to produce, consumer has to consume. The producer-consumer problem is a classic synchronization problem in computer science. There are two types of process. One is producer, that is one thread, and another is consumer, that is also another thread. Now, producer and consumer thread, they have to communicate for using a common buffer area. That is my resource, common. So that common area which is having a fixed size, that has to be used by the producer thread as well as consumer thread. This is my resource. Okay. The producer job is to produce the item and put them into the buffer. So in the buffer area, producer has to put. And the consumer job is to consume the item from the buffer. So the buffer area will be utilized by producer. So whenever the producer produces item, it has to put in the buffer. This is my buffer. This buffer, which is filled with some item that has to be consumed by the consumer. As long as item is not there, then the consumer has to wait. Or as long as the buffer is full, producer has to wait. Whenever the buffer is empty, producer will produce. Whenever the buffer is full, consumer will consume. So it will be using wait and notify signal. The challenge is to ensure the producer does not produce item when buffer is full. So here the main challenge is the producer should not produce the item whenever the buffer is full. Similarly, the consumer does not consume the item when buffer is empty. So under this situation, they have to go for wait and notify. Producer, consumer, and in between buffer. Producer is producing the item, storing in the buffer. Consumer is consuming the item from the buffer. Now let us see how to write a program for this. So for this, for producer consumer problem, what are the programs I need? I need a resource area. This resource area will allow me to use by the multiple thread. So here the shared buffer is my resource. In this resource, I am having a small area called buffer. It is a linked list, a set of integers, So now producer will produce set of integers, then the consumer will consume. So initially my capacity is how much? Something I'll say, because my limited buffer, assume 1, 2, 3, 4, 5, 6. That means I can store maximum 6 items or 6 indices I can store. Then I will write two methods. One is for producer, another for consumer. These two methods are my synchronized method. Because once I enter into the synchronized area, others should not disturb until I go to wait state. As long as I am using, then other thread has to wait. Because a common resource is only one that has to use by other threads with mutual understanding. That means there must be some cooperation. So it requires cooperation among the threads. So now my producer method will have a synchronized method. The consumer method will have a synchronized method. This synchronized method will allow only one thread to use. Let us see how to write a producer method as well as how to write consumer method. Producer method is producing some item. This item I have to put in the buffer, my linked list buffer. So whatever the buffer I am having, that buffer I will utilize. So this method is what type? It is a method which takes an integer, returns nothing, and is a public accessible, and it may throw exception because sometime the runtime error may comes. If runtime error comes, I should have some mechanism to control it. For that, I am throwing the exception. Synchronize the block. Once I enter into the synchronized block, other thread cannot enter here. Synchronize this. Here what I will check, what is my buffer capacity and what is the original capacity. If the buffer size is equal to original capacity, then I said that I don't have place to store. If you do not have a place to store, then you have to go for waiting state. As long as the buffer is full, then producer has to go for waiting state only. That's why I wrote here wait. If it is not full, that means if the size and the capacity is not equal, then the loop will stop. Here, I will add the item. Whatever the item I am sending, this item I will add to buffer. Initially, of course, my buffer is empty. Here, assume my item is 3. So 3 will be stored here. After storing, now the producer says, yes, item I kept in the buffer. Item is kept in the buffer. Now after putting, because earlier it was empty. Earlier it was empty. After putting the item 3, then my duty is what? To notify. Why? Because the consumer thread is waiting to consume the item. So once you say notify, the signal goes to other thread who are waiting. So this is the role of producer method. This producer method will be used by producer thread. And there is one more method called consumer. The consume method. Consumer method means the consumer thread will use consume method. Now see consume. What it will consume? Whatever the item is there, the buffer, that item I have to consume. So here also I made a synchronized area, that means the critical region. Once I enter here, my first duty is check whether buffer is empty or not. If buffer is empty, can I consume anything? Nothing. So if nothing is there, then I have to go for waiting state. Go to waiting state. In the earlier case, if the buffer is full, you have gone for waiting. In this case, if buffer is empty, go for waiting state. If it is not empty, that means some items are there. In that case, I can remove the first item. I can remove the first item from the buffer because it is a linked list. I can consume the first item, then second item, then next. So take the first item and print it. Yes, consumed item. Once the item consumed, then I can send a notification. Yes, I have consumed it. You can put into the buffer. So that means there is a cooperation between two threads. What are the two threads? Producer thread as well as consumer thread. And both are using what? A common buffer. Common buffer. Now, these two methods are available in my buffer. Producer method and consumer method. Now, producer method will be used by producer thread. Consumer method will be by consumer thread. Let us write two thread. I will write a producer thread, which is behaving like a thread. I told you, I think in the previous session, thread can be implemented by two ways. Either by extending thread class or implementing runnable interface. So, you can implement runnable interface. Once you implement runnable interface, then this class become act like a thread. If you are not implementing runnable, then that is not a thread. That become normal class only. So, to make a class to be a thread class or thread behavior, then either implements runnable. Runnable is what? It is interface, or extends thread. Once you extend the behavior of thread class, then that will also behave like a thread. So you can follow the first technique or you can follow second technique. Here I have used the first technique, runnable. After that, a common resource, my buffer. This buffer I want to use. That is the shared buffer. I am having the object of shared buffer, and I want to make the thread to be start. So make a thread object. Pass the buffer. This buffer is my common resource. This common resource can be shared by both the thread, producer thread as well as consumer thread also. So this buffer and make the T object to be ready. Then T dot start. Once you say start, now it is ready to run. It is ready to run. Now it will go to ready state. It will go to ready state. After that, this ready state is linked with one method called run method. Here you write the logic. What is the role of producer thread? It has to produce the item. How many times? I may produce any number of times. For example, I want to produce 5 times. So my loop is repeating 1, 2, 3, 4, 5, 6, like this up to 5. 1, 2, 3, 4, 5. Produce first item, put in the buffer. Produce second item, put in the buffer. Third item, fourth item, like this. I may produce multiple items. But after producing each item, I have to send a signal to my consumer. So that's why I am sleeping here. How much? 1000 milliseconds. Because produce one item, sleep for 1 second. So that I am in the sleeping state. Then there my produce method, what it will do? It will put into the buffer. Then it will go for waiting state. Once you go for waiting state, then the consumer thread is getting chance to consume. So Like this, it is repeat 5 times. If at all 5 times are over, it says my work is over. So because my goal is to produce 5 items. Produce 1 item, consume. Produce, consume. Produce, consume. Produce, consume. Now, there is one more class called consumer thread. This also derived from runnable interface. It is also having a buffer. And use the buffer and have a connectivity to thread. Assign the buffer and start it. That means my thread is static. That means both are ready to use the common resource. Now, the run method, what it will do? It will try to consume how much time? Because you are producing 5 items. Now my responsibility to consume 5 items. So here buffer.consume. Earlier I wrote buffer.produce. Here if you observe here buffer.produce in producer class. Whereas in consumer class I have to consume. Here consume. Whatever item you have produced already, same thing I am consuming. Then this fellow is sleeping. Once this fellow sleeps, then the consume method, we will go there, consume it, then send a signal. Yes, I have consumed. Like this, there is a cooperative nature between the two threads. Now let us run. For running, you have to write the driver code. The driver code, that means the main method, publish static void main. Here, I will create one object of buffer in the common source or common buffer. Okay, my capacity is only 1. That means my buffer can store maximum 1 item at a time. Capacity is only 1. But I want to produce 5 times. Produce 1 item, consume 1 item. Produce 2nd item, consume 2nd item. Produce 3rd item, consume 3rd item. Produce 4th item, consume 4th item. Produce 5th item, consume 5th item. Produce 6th item, consume. That means this buffer can store at a time 1 because the capacity is 1. So I cannot override the item. I cannot override. So my synchronized method will allow only one thread to use, and after using it will go for waiting state, then send a signal. Like this it has to do communication. Then produce one consumer thread and producer thread. Both the threads are there. Once the thread is there, then it will say start. Once you say start, this method will run. Similarly in producer also, this is also running. This method will run. Now it will work. Okay, so this is the way it works. Let us see how it works. I'll show you in the system. Yeah. Now this is my shared buffer with capacity. Initial capacity how much? Assume I will pass 1. That means I can store only 1 item. My capacity is to store only 1 item. Once the item is full, then consumer has to consume. Once the buffer is empty, producer has to produce. So for that, you have sent a signal. So my shared buffer having 2 methods. One is for producing and keeping the item in the buffer. Second is for consuming and consume as long as it is empty. If it is empty, wait it, because consumer cannot consume if it is empty. If it is empty, I have to wait it. If it is not empty, then I will take the item from the buffer. Take the item from buffer. After consuming, send it, then send a notification signal. Now please observe here, in both case, wait, notify, wait, notify. One fellow will be using wait, another will be sending notify. Wait and notify. Like this they can communicate. Now this is your producer problem, producer thread. The producer thread having a thread object. This thread object will initialize the thread. Once you say start, it will try to override these methods. This method is running how many times? 5 times. 5 times the items are produced and kept in the buffer. This buffer will be utilized by the other thread. Let us run it now. This is the main method because the buffer has to produce. Similarly, the consumer thread, It has to consume. Now see. Now my consumer thread is ready to consume the item, whatever the items are produced by the producer. Now see. Now this is my, then the main thread, driver code. This is the driver code. Now the driver code will try to utilize. Fine. Now my producer consumer problem is ready. Let us run. Go to command prompt. Open info. Clear the screen. Java C. Producer consumer problem. Yes, compile it. Now Java producer consumer problem. Now run it. Yeah. Now see, observe here. Produce 1, consume 1. Produce 2, consume 3. Produce 3, consume 3. Produce 4, consume 4. Produce 5, consume 5. That means 5 items are produced, 5 items are consumed. That means I am not producing continuously 1, 2, 3, 4, 5. Produce 1, consume 1. That means there is a cooperation. As long as this fellow is not producing, I will be waiting. Once produce, consume it. Produce, consume. Like this, there is a communication between the threads. If at all, assume you want to produce 10 times. In that case, what I will do? Instead of 5, I will make it 10. 10 item I will consume. So that means there must be 10 times also 10. Produce it. Now, this fellow wants to consume. Yeah, produce 1, consume 1. Produce 2, consume 3. Produce 3, consume 3. Produce 4, consume 4. Produce 5, consume 5. Produce 6, consume 6. 7, 7, 8, 8. See, after producing, it is waiting. 10, 10. Like this. Now, after 10 times, the task is over. Now, the thread goes to, of course. Now, if you want to say, you can print a message also, whether my main thread is waiting or not. Assume, here you want to check whether thread is waiting or not. System dot out dot println main thread. Actually, main thread is controlling the child thread. Now, let us check. Main thread should come. Main thread should say bye bye. This statement should come at the end. Whether it is coming or not, let us check. Clear the screen. Compile it. Now see, main thread is printing that, but that message should not come in the beginning. It is coming at the beginning itself. That means main thread has stopped. Now, in that case, this producer and consumer thread, they become orphan thread. So, I don't want to make it orphan thread. So, what to do? So, to avoid orphan threads, I will put those things in a join state. So, I will put try. So, catch exception E. Now here C, P should join. P is my one thread and C also join. If you write these two methods, then it will allow the parent to wait until the child completes. As long as the child have not completed the task, the parent cannot complete. The parent has to wait. The parent cannot go to that state. If at all any error comes, I have to print it. System dot out dot println E. Control S. Compile it. Yes. Producer consumer problem. Cannot find the symbol join. So join method is not that because I have implemented runnable. So to make it join, what I have to do? Because under P there is a thread of the T dot join. So P dot T dot join. Clear the screen? Yes. Now compile. Now run it. Yes. Earlier the main was complete. Now main is not complete. Main will be waiting until both the thread completes. Now see the by will come at the end. Now you can observe 8, 9, 10. Now the main thread is saying by. So this is the way you have to write the program. So always main is the parent thread. Main is the grandparent. So this is the way it works. I hope this program is okay. So this synchronized area is the critical area which will allow only one thread to use. If you now let us see Control X, public synchronized void, Control C, Control X, Control S. Compile it. Java line number 14. This I will remove this. I will remove this. Simply remove this. Remove this. Now I removed this block. I made it as a method, means synchronized method. Yeah, now it is working. Earlier it was giving error because that block should, earlier it was synchronized block, now made it to synchronized method. So you can create that block either through synchronized method or synchronized block. Now observe here. Yeah. So synchronization can be done by two ways, either synchronized method or synchronized block. So now it is synchronized method. Now the complete method is synchronized. Once one thread enters, other thread cannot enter here. So this is the nature. So for communication between the thread, always use synchronization concept so that there will be a cooperation between them and there should not be any overlapping in the nature. For smooth communication, always go for synchronization concept. Yeah. So the main concept what you learn, the wait method as well as notify method. This fellow is waiting because the size is full, and once it is full, wait. If it is not full, produce it, then notify it. Similarly, under consumer method, if it is empty, wait. If it is not empty, come here and use it. This is usage. Use buffer. Use buffer means consume the buffer. Consume means take the data. You are taking the data from the buffer. Then notify it. Once you consume, that buffer is empty now. After empty, send a notification. That means you are sending signal. Sending signal. Once you send signal, then this fellow which is waiting now, this will be getting a signal. Yes, do it. Now it is capacity is not full. That means some empty is there. Come here. Then add an item or produce item. Produce item. So this is the way. Then you are sending a signal. It goes to waiting state. Here it goes to waiting state. Waiting state. Then here sending signal. So this is the way it works. So I hope it is clear. So now please practice this program in your system so that you will have a complete idea on inter-thread communication, how two threads can communicate each other. So for that, what you need? You need a common resource, means common buffer, where both the thread will be using one will produce, one will consume. Similarly, you need to thread the producer thread as well as you need a consumer thread. Then you need a driver code where both, that means the parent thread which is controlling both the child, first child and second child. I hope it is clear. So this is the way you can write your inter-thread communication. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.